Last little bit here. It says find the inverse of the following and then verify the answer is correct by creating two compositions. So you do f of f inverse of x, so you're plugging the inverse into function f, and f inverse of f of x, so you're plugging in f of x into the inverse, which should give you the exact same output of x. So let's start with this. Again, temporarily switching it to y equals, so we got y equals 5x minus 8. Next up, we're going to switch the x and the y and start solving. So we got x equals 5y minus 8. To start solving for y, we're going to add 8 to both sides. So we'll do plus 8 over here, plus 8. We got x plus 8 equals 5y. To solve for y, let's divide both sides by 5. And we end up with x plus 8 divided by 5 equals y. In other words, we get f inverse of x equals x plus 8 over 5. Sorry, it's a little sloppier. I left my stylus at work. I'm doing this at home right now. So we got x plus 8 over 5 is our inverse. So now we're asked to do the composition. So f of f inverse of x. Let's do that first. So f of, let me switch, actually let me do this. Let me switch to red for function f. So we got f of f inverse of x. So in other words, we're going to plug this inverse into function f. So it's going to be f of x plus 8 divided by 5. So that means we're going to plug in x plus 8 over 5 in for the x in the original function. So the original function was 5x minus 8. So we're going to do f of that x plus 8 over 5 equals, pardon me, 5 times that x plus 8 over 5. And then we're going to subtract 8 from there. So let me shift that so I'm not covering it with my head. So we're going to cancel out the 5's. The 5 and the divide by 5 cancel out, so we're left with x plus 8 minus 8. And when we simplify that all down, we end up with just x. So f of f inverse of x equals x. Let me shift that a little bit. So f of f inverse, exactly what we're hoping for. F of f inverse of x equals x. They cancel each other out. Let's try the other direction. So now we're going to try f inverse of f of x. So we're going to plug in function f of x into f inverse. So we have f inverse of 5x minus 8. So we're going to plug in 5x minus 8 into the inverse function. So we'll have, instead of x up top, we're going to have 5x minus 8. And then we're just going to, so we're replacing that in function, or the inverse function. We still have that plus 8, and we're going to divide it by 5. In that numerator, we got a minus 8 and a plus 8. They're going to cancel out, so we're left with just 5x over 5. And when we reduce the 5's, we're just left with x. So we're going to say f inverse of f of x equals x as well. So that's what we're hoping for. We're hoping to get, when we plug the composition in for f of f inverse and f inverse of f, that they both give you an output of x. Last one, f of x equals square root of 2x plus 10. Again, temporarily switching it to y equals. So we got y equals the square root of 2x plus 10. We're going to switch the x and the y, so we have x equals square root of 2y plus 10. To start solving for y, we're going to square both sides. So we got x squared equals, on the right side, we're just left with 2y plus 10. Let's subtract 10 from both sides. Sorry, getting ahead of myself. So we have x squared minus 10 equals 2y. To finish solving for y, we're going to divide both sides by 2. And I'm just going to leave it as x squared minus 10 over 2 equals y. In other words, f inverse of x equals x squared minus 10 over 2. Sorry, I'm off the screen. There we go. So that's our inverse function. So now we're going to do what we did on the previous problem. We'll do f of, and then we're going to plug in the inverse function. So we're going to do f of the inverse function that we just got. We have x squared minus 10 over 2. We're going to plug that whole thing in for the x in function f. So it's going to look like this. We're going to have the square root of 2 times our x value. Well, our x value is now that x squared. Let me color code this a little bit better. X squared minus 10 over 2. And then we have that plus 10 that was still underneath our square root. Sorry, let me go back to that. That was from the original function f of x. So we have plus 10 on the outside. Cleaning this up a little bit, those 2's are going to cancel out. So we're left with the square root of x squared plus 10 minus 10. Well, the plus 10 and the minus 10 cancel out, so we're just left with the square root of x squared, which is just x, which is exactly what we're looking for. So we're looking to hopefully have it where we plug the inverse function into the original function and get x out of it. Let's try it the other way. So now we're going to take the inverse function and plug in the original function. So that means we're going to do f inverse of the original function, which was the square root of 2x plus 10. So when we plug that into function f inverse, it'll be square root of 2x plus 10. Sorry, there we go. Then minus 10, all that divided by, oh sorry, I missed something. Squared minus 10, all that divided by 2. So we're replacing the x, we're replacing specifically this x up here, in that x squared, with the whole f of x function. So going through this, when we square a square root, we're left with just what's inside. We have 2x plus 10, then still minus 10, all over 2. Cleaning up that numerator a little bit, the 10's are going to cancel off, so we're left with just 2x over 2, which again simplifies down to just x. So if the inverse function, if the composition of the inverse function and the original function are truly inverses, then they should simplify down to x when you do composition.